Hello, my name is Matthew Papish, and this is the demonstration for the DC motor project. As an overview, I'm only going to talk about the components, talk about the circuit that's actually in front of us, and then I'm going to talk about how it operates and then actually run the motor or run the circuit. So, um, in terms of the circuit, we'll start there. These cables here, these wires here, go to a block that is plugged into an outlet, a 120-volt outlet, and that block is converting the AC to DC or direct current, and that load is supplying that direct current to this positive terminal, which is wired in series to the switch here. This positive terminal then travels from the switch to this brass strip, and as you rotate this, so you can't tell yet, but there's a crankshaft present in the back behind this flywheel. And as you rotate that crankshaft, it does at some points in time come in contact with the brass. And that crankshaft is conductive and wired here to this coil wire, which is wired in series to the negative terminal of that block plugged into the outlet. So that means that as you rotate this crankshaft, whenever the crankshaft comes in contact with the brass, the circuit closes. And then when the circuit closes, it will supply a current through this coil wire, creating an electromagnetic field. So that's the circuit. In terms of components, we have this mount here of a couple blocks of wood, two metal brackets, which have a coil wire wrapped around a plastic tubing mounted to it, which allows this ferromagnetic cylinder to oscillate in and out of it. As for the crankshaft over here, we have a flywheel attached to it. If I were to rotate it, we can see that if I angle this a little bit or rotate it a little bit, we can see that the crankshaft is bent to where that as I rotate, when this ferromagnetic cylinder is furthest from the coil, that's just in that moment of time, the brass comes in contact with the crankshaft. And then as I continue to rotate the crankshaft, the moment that the crankshaft is no longer touching, it's hard to tell, but when it's no longer touching the brass, the cylinder here is all the way into this plastic tubing. So that's the general idea for how this works. So we have, again, this mount here with the coil on it. We have this ferromagnetic cylinder here. We have this crankshaft with flywheel, this brass strip here, the switch here, and that's kind of the gist of the project. So the way that this operates is that when the circuit closes and this coil has current traveling through it and that electromagnetic field is created, it's going to attract this metal rod here, this metal cylinder. I guess I'll call it a rod going forward throughout this video. So the idea is that when I rotate this crankshaft, it's going to come in contact with this brass, closing that circuit, allowing this coil to create an electromagnetic field as current travels throughout the entire circuit, and that will actually pull on this rod here. And when it does, it will allow this crankshaft to rotate and do about a half of a revolution. And then at that moment in time, it's just barely no longer touching the brass, the crankshaft isn't, and that's because of this foam over here. This foam and electrical tape, although it's a mess, it is pushed to the right just far enough to where this brass is placed just to the position of where it's just below the crankshaft. So at this moment in time, it's no longer touching, right? And in doing so, there's no longer an electromagnetic field present because the circuit is open and there's no current flowing, and allowing the rod to no longer be attracted to the coil. So now there's no longer some sort of force being pulling on this rod here. So since the circuit, or since the field had the rod be pulled in, and this crankshaft is rotating, the moment that there's no longer an electromagnetic field present, there's already angular momentum built into this flywheel. So That angular momentum allows the crankshaft to continue to rotate, and without this electromagnetic field present and nothing pulling on the rod, that momentum, as it rotates the crankshaft, will pull the rod back out again until the crankshaft continues to revolve to the point to where it touches the brass again. And in doing so, it then closes the loop as the circuit closes and the electromagnetic field is created again, and it's induced, and then pulls on the rod to repeat the whole cycle. So that's how this project works. I'm going to power it up and by flipping the switch, and then as I give this a little, as I rotate this flywheel, it should start to run the motor. So that's all I'm going to say for this project. I'm not gonna go into any more detail as to the DC motor project, mostly, or this project in front of me, mostly because it is from middle school. But despite that, it is most definitely an honorable mention. It is most definitely an inspiration for when after I made it in 8th grade. And I like to think of it as a starting point for all of my projects that I've created throughout my 4 years of high school. Thanks for watching.